our economy. Here in 2017, The Economist compared the big data companies with all platforms. And even if the name is very similar, both are platforms in some way, data is unlike oil. In very many ways, we have data as freely replicable, so it doesn't necessarily make data less or make data worse if it's going to be copied. And there's also a part about data that data very much depends on context. But we're going to talk about something very specific today, and that's data is social. Social means that when I make a decision to give away some of my data, then this also affects others. And this very specifically also affects others in how much value their data brings to a specific task. And this will reappear and reappear in the form of bargaining power. The structure of our session is, well, you will have some time with me. I'm going to give you the introduction and tell you some story, and I will set you up for the discussion groups, which are then 25 minutes. The setting up for is a typo there. And in these discussion groups, you will have tools to write and report on what you find in questions and discussions you have. And these will be briefly shared at the end. But we will also collect and compile the writings out of these and publish them on the website that we created for this short tutorial in about a week. Now, on social data, back to social data, we have the logistics out of the way. Social data might actually also lead to some behaviors that we don't want. And I'm going to give us, before we really start, one thing which is even inside of economics called a paradox, so-called digital privacy paradox. In research, which was published in 2017, Susan Athey and a few collaborators did experiments about sharing of email addresses with undergraduate students in the US. And they generalized their finding to all consumers. And they say consumers say that they cared about privacy. But at multiple points in the process, they would end up making choices that are actually inconsistent with their stated preferences. And I hope to convince you in about half an hour, when I will re-show this quote, that you can have an argument why this actually is not so paradoxical, and that it might just be an environment of how our data economy looks right now. Okay, first, a model, which then leads into observations and then into critique. And here, another nice quote, because it's a translation tutorial from economics, so some advertisement for economics. Keynes, and another important economist from the beginning of the 20th century, some people would also call him more an econometrician. He says, economics is the science of thinking in terms of models and the art of choosing models which are relevant for the contemporary world. And here it's also one important thing. I'm proposing a model. It's not going to be true. It's going to be very reduced, very stylistic, and it hopefully brings us some insights into what things are really crucial in the observations that we make. Okay, in a model, we have some parts of the model. As we could think of different agents in a reinforcement learning setting, if this is your style, or we just have people in an environment. And here we call them players, because for economists, many things are a game. And here we are looking at a very reduced example, which is just barely enough to show how something like a data externality, so one sharing decision affecting someone else, can show up. And this is the case of two users, that is user A, Andy, this is me, and Bob, which is not here. I don't know. Do we have any Bob? I don't see, at least in the names. And there is going to be platform. And we're going to study an environment where first platform proposes a data use agreement, something that we will need to model in our model. And then users individually decide whether they should join the platform, so accept this use agreement or not. What is the data use agreement? I here copied from the Facebook data use agreement, and they state a couple of things. So Facebook collects information about how a user uses Facebook products. For example, they log what posts, videos, and other content you view. They use the information to personalize features and content and to make suggestions on Facebook and off Facebook. And this data will also be stored for some time, either when Facebook deems that it's not necessary to have this data anymore, or until data is deleted. And looking at these usage agreements, one very rough picture of it might be, oh, there's something that I know about myself, which I share once and for all with Facebook. And this brings us to this first piece. Okay, how are we going to think about this user agreement? And for this, we need a model of information. Sorry, just questions come up in the chat. We will have a person, Mihaela, from our team, who is going to respond to content question in the chat. And if you have questions that really you think that you will lose the thread of this, do also interrupt me. That is okay. For more logistical questions, there's also Killian here. You can send a personal message if it's related to some things that you might not be able to join, or it's more generally related to FAccT. Let's come back to these user agreements. So we would like to have a model about what does it actually mean for me to accept a user agreement. And for this, we need some model of information. And in economics, information is thought of as a realization of a random quantity or a random variable, more technically. And like in a physical experiment where people would agree that an unbiased coin that you flip has odds of one half for either of the two sides, we also agree, to make this model simpler, that all the users and the platform agree on a prior distribution for this. And then we say, me knowing or owning my data means that I see the realization of this of a random quantity XA, which will be Andy's information. And Bob sees the realization of Bob's information. And the distribution of our informations together, that is agreed on by both users and the platform. One example of such an information could be, for example, the preference for vegetarian food that we have, which is also something that could be quite interesting for an advertising platform, and that will be reoccurring throughout the first part of this presentation. Then, so we talked about what user agreements are. Let's make a bit more specific. How actually are our three players, so platform and the users, are going to act? And we assume that they're strategically doing whatever is best for them, assuming that no one else they can coordinate with. So everyone does the best, assuming that everyone else still does what they do. So they're very selfish. So selfish in the sense of just only thinking unilaterally about what they could do. So platform makes a proposal, they just put it out, and they then expect the users to think, okay, so other users are also joining, or other users are not joining. So what is the best for me? Should I join or should I not join? And this thinking at the same time, all of the users have. And this is why on the right-hand side, I put platform proposing a user agreement which will feature reveal X and get B. That will be a service that I introduce on the next slide. And then you have users side by side next to each other, thinking at the same time, should I join or should I not join? Then I said already that platform and users agree on some distribution. And here we are going to make this a very specific one to make calculations in a way that I can even show you something as a derivation from a mathematical model. And this distribution is that my taste for vegetarian food and Bob's taste for vegetarian food are both standard normally distributed. This is just one nice distribution of a random variable. And if you're not as familiar with the normal distribution, just think of it that this is a distribution where we quite well understand how much variation this random quantity has. They do not need to be independent necessarily. And this, the image on the right shows, there we have two distributions where the left one could show my, looked at it from my perspective, preference for vegetarian food, which is a standard normal random variable, a bell curve. And also for Bob, it's the same. But actually, when you look at the joint distribution of us, it's a very much non-circular thing. It's an ellipsis because we are actually positively correlated. If I like vegetarian food because Bob is my friend, they might also like vegetarian food. Platform moves first, and there's this catch that somehow we need to also benefit from something, and they offer some service. This service could be a very high quality mail program. It could be a perfectly working streaming service. It could also be a library of most videos on the world. And these products, for example, we see in a similar model in Gmail and YouTube, if you're just staying inside of Google's ecosystem. If A or B decide to accept the service and accept the user agreement, then the platform observes their information XA and XB. Now next, for more machine learning audience that might be clear, okay, there should be something that we optimize, some loss. In economics, there is also a strong focus on that everyone participating, all the players are optimizing something. There is some objective that typically is written as a maximization problem, a utility is it then called inside. And objectives here will be about how accurately platform knows something about the information. So how accurately can platform know my or Bob's preference for vegetarian food? And for this, we need two pieces of notation. The first is this ACC for accept. This is the group of people that joins the platform. This can be either A and B if I and Bob join, or A if only I join, or B if only Bob joins, or no one of us. And LA of ACC is then a loss. This is a loss function, which here technically in the method I write down will be the so-called mean squared error, but you can just think of something, if I have more information, then the loss of estimating, I as a platform, will go down. And platform's objective is to minimize loss, net of whatever it needs to spend to offer a service. So here, platform would like to minimize the loss in estimating A, this is LA, given the group of agents that join the platform, plus LB of the same, so LB of the group that joins the platform, plus the cost that it spends for service. And because economists like to write this as a maximization problem, this is equivalent to maximizing the negative of it. Users maximize a weighted loss. So they have some parameter, which is their privacy awareness, VA, which tells how much actually does it hurt you to be accurately estimated. And I will give on the next slide some some examples of where actually this preference for privacy might come from. So they maximize somehow VA times their loss they get from being estimated, and they get plus the service because they enjoy the service. And what we see here is that users and platform have a conflict of interest. While the platform would like to minimize loss, the users would like to maximize loss. But they only do so with some variation given by this privacy awareness. And this is where a lot of the magic happens, or which will come up in the future. So where could this come up? And here we could look into so-called instrumental values of privacy, which is here I really think strategically about what it could mean if my data was shared. There are also other inherent values of privacy, which are less strongly captured so far in economics, but these four that I have on this slide are quite well modeled. So I move out of the way. The first is price discrimination, which is given more information, prices and also offerings can be adjusted to you, and that can be good or bad for you as a user, but for a platform, it will be something good, or for a seller, it will be something good. The second one is advertising. And in advertising, you can offer better products. And this can also lead to some better matches, but also depending on how you work as a person, it could lead to you buying much more expensive products. It can lead to personalized services, which we see in platforms. And it could also lead, in the case of data, which is around pre-existing health conditions, to persons not getting any insurance anymore, which is then a very strong conflict of interest between users and platforms. And all these would inform some value of this VA that was on the last slide, which can be very high if users very much care about their privacy, or which can be rather low if they're less privacy. Just checking in with Mihaela, is there anything that I should address now from the chat? Okay, otherwise I'll go on. I will also respond to these during the breakout rooms. So feel free to interrupt me if there's something you would really, you need to have. Then these are, what exactly is VA? So VA is a number, which could be 1/2, which means that if the loss is decreased by 1 of estimating any of my things that, any of my parameters. So here we're also thinking it's one number. So my preference for vegetarian food can be estimated by 1 better. So there's less variance, one could say, in that of 1. Then it needs to be weighed off a service in the quality of 1/2, which is this BA, to make me feel the same. So to give me the same objective. So this really governs the trade-off of things that I get outside of and things that I feel from being estimated. Okay, these are unfortunately static slides. That's something that I didn't discover in Zoom, how to make this work with animations. So let's, I put you on the right a glossary that will appear on a couple of slides. So if you feel quite lost, then you can look up there what we have X, V, L, and B. So there, that maybe helps you. So let's recall. So this slide is really going to be the punchline. It shows us that first, the platform doesn't need to offer much. The next slide will really show, oh, it's very strong what the platform can do. Recall, we assume that the preference for vegetarian food or whatever information I and Bob have are distributed in this nice distribution N01. And we now are going to, in addition, assume that we are very similar. So our covariance is very high. If I have a high value, then it's also going to be very likely that Bob has a high value and vice versa. And we assume that there's some difference in our privacy awareness. VA is 1/2. When I just responded to the question, then we're this case. So I feel, for me, the trade-off between privacy and the service quality is 1/2. For Bob, however, it's a lot. It's here I only write greater than 1, but think very high. So let's first see that the platform can offer me a service of 1/2, and I will join, no matter what Bob does. And here we can look at two cases. First, let's look at the case if I don't join. So what is my objective? I don't get a service because I don't join, but I'm estimated in some way. So I will get some, I will get VA, LA as my loss. So this is like, it gives me something good that I'm not estimated so accurately. And this must be smaller than 1/2 because VA is 1/2 and LA is the loss of estimating what I have. And here it's a property of this nice distribution, standard normal distribution, that the loss that we're using is at most 1. It's exactly 1 because it's the variance of this one. So what I get if I don't join is 1/2 at most. Let's now look at what I get if I join. There, okay, VLA is somehow the error that is done in estimating me. This is a number which is going to not be negative. Because I join, I get the service, which is, by what we assumed, at least 1/2. So here, this is like 1/2 could correspond to, I also have intelligent email filtering, and I can get reminders for emails. And together, taken together these, we have 1/2 plus a non-negative number that is at least 1/2. So what we see is, okay, I, by joining, am no worse off than by not joining. So here, if I get exactly 1/2, one would need to look like what happens. But if I'm offered 1/2, I will join. The platform can actually do much better than that, though. But this was just to give a feeling of how these arguments work. If I join, then because so Bob and I are so similar, Bob's data is almost completely non-related to the platform. So Bob needs to think, assuming I join, okay, what can I do? So B will join for almost nothing, because all the harm that is done already from being estimated for B has already happened because I shared my data. So B will accept almost no reimbursement. But if now Bob joins for almost nothing, then my data is almost completely known to the platform. Hence, I will also not demand much from my data, and I will join for also almost 0. Platform can hence really offer us almost nothing. And this is a data externality in a mathematical model. Each user, so I and Bob, if we decide to share, we have a negative data externality on the other. We don't take into account what effect it has on the other user that we share. We only optimize for ourselves, and that in turn leads to both of us sharing for almost no money, like a person that wouldn't care about privacy, even though Bob actually does. Okay, we saw this. And now in the culture of microeconomic theory, or maybe also more broadly economics, now the question is, okay, this is a nice story, this is a nice example. Let's try to see what more generally happens. And what we saw, and this is something where I want to give you a glimpse of how this could look more, a bit more generally, is we saw that data sharing somehow was excessive. It seems to be that people share too much, and that reimbursement is low. But the question is then, okay, so if we make these statements, that sounds very political. How can we make this formal, at least? Could still be political, but how can we make it formal? So we would need to ask, okay, with respect to which benchmark is this going to be? With respect to which benchmark is data sharing excessive? With respect to which benchmark is our reimbursements, so this service that we get, B, is that low? Wow, crazy slide if it's not built up. So on the top right, you have again the glossary with the terms if you want to be reminded. The benchmark that is often used in economics is to sum the objectives of the different players. And this makes some strong normative assumptions, for example, that you can trade off between different people, but this is something that is very often done in economics to make some statements. And the sum in this case plays out like the following. We get in the first line, whatever is the objective of the platform. Platform wanted to maximize, so platform wanted to minimize the losses plus the services that it needs to offer. But as we're in a maximization, we have everything with the minus. The second line is for the users. There's VALA, which is the objective that I gain from being not so accurately estimated, and the service I get, that's BA, and the same for Bob also. And as this model is set up, we are going to, we're seeing that the service cancels out, and we see that there is a factor, VA minus 1 and VB minus 1, in front of how the objective of being not so accurately estimated. So now we said our benchmark is to maximize this one. So what we would do if we want to maximize this one is to say, okay, a quantity where VA minus 1 is greater than 0, is positive. So there's a positive coefficient. There we want to have LA large. So if VA minus 1 is greater than 1, then let's not estimate it very accurately. In the case of me, with VA equal to 1/2, that was not the case. There we were in the second case, which was VA minus 1 was smaller than 0, was minus 1/2. And in this case, we want to minimize it. So in my case, we wanted to accurately share and also shared the data, as you saw. But the thing is, we cannot do this independently. LA of ACC and LB of ACC both depend on ACC, so on who joins the platform actually. And correlation imposes a lot of structure on this, and we cannot independently set the loss in this case. So I should take into account the correlation I have with Bob in my joining decision, which is something that we already saw. The problem is, and that we also saw in our example, that all users, for which in our first thinking, we would just individually say, we would like to give away the data, they will share their data. Actually, in a world where the platform plays optimally and the users play selfishly optimally, everyone would give away the data without looking at the correlation. And this is something from which you can also more generally see that data sharing, if people play selfishly, is higher than in our benchmark of summing these objectives. The second observation is to say that the service level or the reimbursements that we get are lower. And here a benchmark is that we say, what would happen if there was no social data? What would happen if I was alone on the world and no one else shared? What would I get for my data from platform? So let's assume B doesn't join. In our benchmark, so B doesn't join is our benchmark, then I would join if I get offered this value, VA times the loss if I don't join. So this is completely, platform doesn't observe anything, but estimates me minus what the platform learns if I join. And here, I now guide you to look below the orange line. So here we can make again a comparison that as we did before. And here I'm going to move a bit to the center. No, that doesn't work. I can actually move myself around, which is really cool. If A doesn't join, so we assume B doesn't join and A doesn't join, then A doesn't get the service, so doesn't see any BA. And also no one joins the platform because A and B don't join. So what the platform can estimate is LA of this empty set because no one joins. I feel it as VA times this empty set. If I do join and I get this quantity that I wrote up here, VA times LA empty set minus LAA, then I get, well, VA of LA, this should not be an empty set, that should be an A because I join, plus whatever I get. And here in the second line, the greater or equal there, it's correct. So VA LA empty set, this is the same as the VA LAA. And we just plug in for BA the term that was up in the bullet. And what then the crazy mathematician who likes variables sees is that VALAA and VALAA at the beginning of the at the end of this second to last line actually cancel out, and it only remains that VALA of empty set remains. So we are again in a situation where if I don't join, I get at most as much as if I join. So I can be offered this value. A similar argument shows that if B was joining, I would give a similar term where we just assume that B already has joined. So LAB and LAAB instead of LA empty set and LAA. And one property of random quantities or random variables, which is called submodularity, actually shows that there is an inequality. And that drives a lot of the results in some of the recent research from, like this year, you see it on the left where I always put the references. And what we see is hence that if other people join, and we see that because there is excessive data sharing, then reimbursements are lower than wanted. Okay, now let's critique this model. And this brings us to discussion groups. I showed you so far a model. I derived you that data externalities exist. And I also showed you that they exist not only in a made up story, but a bit more generally, if there is just some correlation structure between, or some similarity structure between me and Bob. And here, these assumptions that we're going to look at are going to be critical assumptions, because critical assumptions have a nice feature that they can change things. Danny Roderick, another economist, writes in his book Economics Rules, an assumption is critical if its modification in an arguably more realistic direction would produce a substantive difference in the conclusion produced by the model. And here we have a model, and we were actually maybe as here a FAccT community even more interested in interventions to change something which is not arguably more realistic, but might just inference something into another direction. And here, critical assumptions in a model can help to identify these channels where change can actually create something different. And I'm going to present you 3 critical assumptions, which will be our 3 discussion groups that you can choose to join. And they're called the data substitutable, a word that I need to define to you, that contracts are only signed once in our model, and that every user is approached individually by the platform. I actually prefer it down here. So let's go into data might not be substitutable. And let me quickly check. I think I need to stop sharing for this. So I'm going to quickly show you a 25-second video. Can you see the video? Okay, I cannot hear anyone, but let me just try for now. Otherwise, shout. So what this artist did in Berlin, it's over the Spree in Berlin, is he transported, he transported 99 phones in a small cart over a bridge in Berlin. And I open up the slides again. And the thing that Google Maps thought that there was a traffic jam. And this is going to be, I need to move to where we are. Here we are. And this brings us into a direction that actually there might be a bit more complicated story. And it might not be super clear yet, but actually there seems to be something that we individually, with one phone walking slowly along a bridge, do not create a traffic jam. And we don't even create proportionally a traffic jam according to the number of phones that we have. So it might be that in some environment, platform and users altogether care about some state of the world, which could be the traffic situation in Berlin, or in Cairo, or in Cambridge, or in any other city I like or you like. And what we saw so far is so-called substitutable data. We have data such that the state of the world is already pretty well predicted by everyone else's data without me. This was the case with me for Bob. I shared data, Bob's data, or both of our data was actually quite accurately predicted. This is the case of S, is this list of XA and XB. Another example of this is also if S is something that we are going to train using a differentially private algorithm. There, by construction, we're assuming that taking away a data point shouldn't change much in the output. We shouldn't be able to detect neighboring databases. And this output actually makes it already that all the other data points together must be almost as expressive as the data point with me. On the other hand, there could also be an environment where actually, without another person, I'm actually not informative for the state of the world. And in the Google Maps case, that's certainly the case. One phone doesn't do it. There is some threshold that Google knows that does it. And now it gets nice, and this is going to be what Charles's discussion group is going to be about. That we saw if data is substitutable, then data sharing is excessive and prices are depressed. That we know. I showed you a result for this in this model with two agents. If data is complementary, then we can flip it around. I didn't show you this, but that also can be shown in a mathematical model. Then data sharing is low and prices are high. Here I don't say that data sharing is depressed and prices are excessive, because the question is, what is a good benchmark also here? The second strong observation that we made is shown in the story on the right. Platform could say to users of WhatsApp, here's a user agreement, and you can also share your contact list. It's going to be very comfortable for you to message them. So that is, you share X and you get B. And then everyone thinks, oh yeah, sure, my friends join, I'm also going to join. Platform then says, okay, Facebook and WhatsApp are now integrated. Someone spoke up, yes? Okay, I'm going to continue. Facebook and WhatsApp are now merged, and then it's possible to leave. And the model that we presented so far does not quite capture such dynamics. It's only that the agents decide once. But it is an okay approximation if we don't assume that the platform unlearns any data when someone unlearns any of the information that it has. But actually, this is the case under regulation, which is already in place, for example, in the European Union. If users can delete data, this threat to leave is higher because the platform actually has less power. And this bargain might increase bargaining power and might also increase how much service you get. The third assumption is what happens if users can negotiate together. And there, again, on the right, platform could propose a user agreement to each of them. And then if they could negotiate before, they could think, okay, how can we actually split this service? Can we somehow think about how we can go together to solve this problem that some share, even though it's not good for others? And here in the orange box, I put again what we had before. So these nice distributions, Bob and I are pretty similar. I'm not very privacy aware. Bob is very privacy aware. And let's now imagine that Bob can give me somehow a reimbursement in some form, is nice to me, or we have some other institution of at least 1/2. Then, and for not sharing my data, that's for me perfect. I'm not sharing my data. I'm not myself exposed. I get something, and Bob is also happy. We don't share, and this actually matches our benchmark. So this is exactly right, the to not share data in this case. For this, we so if we step beyond a bit in individual bargaining, we see this. This is our third breakout room. I promised you that you would be able, after the presentation, to resolve the digital privacy paradox a bit. Consumers say that they care about privacy, but they actually end up making choices which are inconsistent with their stated preference. We saw that Bob is very privacy aware. Bob knows, however, that I will share, and I know that Bob will share. And no matter what our privacy preference is, or in this environment, no matter what our privacy preference is, we act as if we wouldn't care much about privacy, but we actually do. We just respond to the environment that we have. So now the breakout room presentations. The first breakout room by Charles, Charles can wave, I don't know, is going to be about substitutable and complementary data. We see excessive sharing of data if data is substitutable, and we see little sharing if data is complementary. And the questions that his discussion group will circle around is, can we identify environments where actually data is structured in a way where this added prediction from one more data point is in a way that data is substitutable, so that it's very, it might be superfluous in some way or not, or is it complementary? How can we identify these? Where is this? And then also the question, which interventions would actually restructure data? Because we now see that the structure of data being substitutable or complementary actually has direct implications, at least in our model, for data externalities. So we can play with this. The second discussion group is with Mihaela, who's also waving, which is about making algorithms forget. And this is about the dynamic nature that I talked about. Here again, the story on the right, okay, Facebook and WhatsApp now merge databases. And in my former slide, I said, okay, everyone leaves, but now they also say, okay, please delete all of my data that I've produced. And if platforms cannot gain insights gotten from users when they leave, users might have more bargaining power. And somehow the question is, what are algorithms for this? And when constructing algorithms, it also comes up that there might actually be some interesting interactions of the right to be forgotten and privacy, which is the thing that we actually started out with. And a third discussion group, which is led by Dirk and by Yixin, is going to be about collective bargaining here. So platform asks, and very many people want to split a reimbursement. Collectively, they can escape from a data externality if they're clever. Maybe they also can't. This is something you will maybe arrive at in the discussion group. But what's certainly the case is that writing the rules is very hard. How can you select whom to share data with? How can you make decisions on how to share benefits, on how to think about this 1/2 that Bob gave me to not share my data? And this is what the third discussion group is going to be about. Here are discussion group leaders with amazing pictures. And before I send you off into the break, here's some logistics. Now, so this will be 10 minutes really for you, but please do rename yourself to put in front of your name a number or 2 numbers or 3 numbers. You can rename yourself by in Zoom going on the participants tab, clicking in participants on hovering over your own name, clicking on more, and then there is rename. If you have problems, do private message any of the organizers that you saw so far. And if you put a number of the ones down here, then the first number you put, we will interpret as your first preference, and we will see whether it's almost balanced. This is all I have to say for now. We will reconvene. Yeah, someone has to run. We will reconvene maybe in 8 minutes so that we are sharp at point back here. Thank you very much. I can stay on to talk, but feel free to walk away. This is like a relaxed part. You don't need to be active. No. So some person asks how to change name again. So in the Zoom button down there, you can you should see a participants button. If you click the participants button, you see all the names, and if you scroll to the top, you see your own name. And if you hover over, so have your cursor over it, there it says mute and more, hopefully, or in some other language. And then if you click on more, it says rename or edit profile picture. And there you can rename. Yeah, and I'm also not a lawyer. I agree with Mihaela's message regarding the terms and conditions and privacy policy. So this was actually a quote from the terms and conditions, and I might have actually said it wrongly. I don't remember, but that's where it's good that there's a recording. I'm on tape, so I can check later on. Information is not lost.
Yeah, there's a question about where the breakout rooms will be. It's in the same Zoom. The breakout rooms will be open in a few minutes if they are not already open, and you will see like an icon on the bottom of like your Zoom, and then there's like breakout rooms. If you click on it, it will show you 3 options, and you can just go into whichever one you desire.
Sorry, I do see these, but they are titled Breakout Room 5, 6, and 7 instead of 1, 2, 3.
Oh, this is interesting. Yeah, I think we can rename them. Because I don't want to mess it up. Can you look at it and rename them to the right names?
Or we can just say them with the understanding that it's just +4 everything, which I think is easy enough. But I just wanted to know whether that's what you want us to do.
Yes, that's it.
Tech support here. I updated the breakout rooms to the 3 titles on the slide. I'm just waiting.
Okay, perfect. That's very good.
Yeah.
So we already have. So I actually think that we look pretty balanced. So if you would like, we could already open the breakout rooms now. And you can start with the chat and start directly in 10 minutes. So whoever is here and listening right now, you can already start. I repeat this every 30 seconds. You can already start moving to the breakout room and meet your breakout room facilitators there for a small chat.
Andy, do we start at 11?
Yes.
Okay, and then I assume there will be like a prompt like a minute before.
Exactly.
Like,
I will tell you regularly when.
Right. Awesome.
What the time is.
And we will be automatically transferred, or do we need to enter?
You can enter, but I think I can also, no, I cannot move you because I can move you actually. So I move you now, Dirk.
Okay, great. So then
see you soon.
I'm joining. Okay, see you later, Andy. Bye.
I think there's still some confusion with the number and the name. So I thought one was data substitution, while what I see in front of
that's
prompt one make algorithms forget.
Okay, this is but I can move you then to number 2. That's sorry, then this was maybe somewhere confusing. I move you to complementarity.
Thank you.
Now you see them, maybe. Okay, move again to the end. So now I like to I just would call on you and give you about a minute to tell a bit what you talked about, and then there's the last slide. So for the group making algorithms forget, who could quickly report what you talked about?
We had a lot of interesting discussions, and I don't want to call on anyone, but if anyone feels comfortable talking a bit about what we've discussed, I think that would be really great.
I can help. I was not there for the whole session, but I can help. So it was basically, I really like the distinction between thinking about it from the data about you versus data by you perspective. So personal information was an intellectual property, but then obviously that distinction is not super clear always. And often we could like lie in between. And if that's the case, then we are not protected by things like GDPR, CCPA, and obviously like IP rights. So that was the part which I found pretty interesting.
Then on collective bargaining, can someone quickly say what happened there?
Yeah, I can give a brief report. So I think we talked about 2 main things. Dirk brought up a really interesting example of Apple receives large transfer payments from Google to place search engines on Apple devices, and Apple devices everywhere. So in these real world like tech examples, these tech companies are kind of serving serving as a collective bargaining unit. But then is this the ideal unit that we wanted? So we asked about what kind of intermediary do we want, which boils down to the question of who can we trust? Is it a group of companies? Is it an independent body? Or can we ask is there any regulations can we do? Can we ask these, whoever is using and store the data to fulfill some duties to regulate in some sense? Or can we try to consider like separation of functions? Like people cannot be both intermediary, but also on both of the transaction sides. And we also, the other thing we talked about was on the social cost. Is there a social cost of not joining certain platform like Snapchat, which is both create incentives to collect data, but also is serving as a data intermediary. And that relates to network externalities, but also, is this the right thing to think about when to think about both network externalities and data externalities together? And there's also fairness concerns when there's disabled people, disabilities prevent them from joining these data platforms, which create biased sample of data. What should we do with that? Yeah, that's it.
Perfect. Thank you. Charles, very briefly.
Yeah, very briefly. So in our breakout room, we talk about like environments where data externalities are present and what the sign of that data externalities is in a few case studies. And we had some really good discussions, and people brought many interesting and different perspectives. And we basically came to the conclusion that, when we talk about complementary or substitutable data, we have to be very context specific. And at the end, we didn't have time to touch upon two open-ended questions, which are how to identify environments with positive data externalities, and also how to design such environments. Yeah.
Great, thank you. Last slide. Thanks to all the facilitators of the breakout rooms. That is Dirk, Charles, Mihaela, Yixin, and also for Rediet for kind of giving us a bump to submit this very short term. Yeah, it was a great pleasure to have you all, and even more in the main presentation. And there's going to be a report in about a week on our website, which is at the MD4SG, Mechanism Design for a Social Good. If you go on their website, you find under events, there is FACT 21 in our tutorial. Otherwise, I will also look up how to post this on Circle for FACT. Thank you very much for your participation. And I hope to hear from you in some way or the other. And I think we are all very happy if you shoot us some email, if that sparked some idea in you. And for all the presenters, I will send you an email in 1 minute with an after party Zoom link for just 10 minutes.